All right, we're going to start in our polynomials unit, and there's lots of fun vocabulary in this that we have to know and things that we have to recall and remember. So take clear notes and make sure you have your vocabulary written down and you have an understanding of it. So the first thing we're going to talk about is what is a polynomial. So in general, a polynomial is a monomial or a sum of monomials. Now, that's a very broad term. It's kind of like saying we're humans. So we can break this down further. So we need to know what a monomial is. So think about a polynomial as a big umbrella, and there's lots of little pieces under it. And as general, we all can be called humans, but we have very specifics. If our gender, our nationality, our looks, our hair color, we can be more specifically identified based on a little bit more characteristics. So we're going to look a little deeper. And our first word is a monomial. So a monomial is, just like the root word says, mono. That means one. It's a single number or a variable or a product of a number and a variable. So for example, this is a monomial. This is a monomial. If I put them together, it's a product that together, because they're a product of a number with a variable, is a monomial. And it can get as extinct as this, as I can have multiple different variables, but because they're all put together as a product, numbers and variables, this is a monomial. Now a binomial, you have the root word there, bi, which means two, is the sum of two monomials. So we're adding them. And we can also think about them as subtracting two. A lot of times people, when I say sum, they'll get confused when I show them something with the subtraction, so we'll talk about that. So if I have 5, which is a monomial, plus x, that's two monomials being added together. If I have 5 minus x, this is a positive 5 and a negative x being put together. So it's still the sum of two monomials. We won't say the difference of them. We would still say the sum. You can think about it as just two monomials being combined together instead of adding or subtracting. You can also think of a binomial as being like maybe 5x, and because we know that's a monomial, plus what we used before, which was another monomial. So that is a binomial because that's a monomial and that's a monomial, and they're being put together or combined together. A trinomial is when you have 3 of them. So a sum of 3 or a combination of 3 monomials. So maybe you have 5 plus x minus a. These are all monomials individually, and they're being combined together. I can think of it this way, 8x plus 2 minus y. That's also a trinomial. Tri means 3, so it's trinomial. If we get above tri, they usually don't call it any more specific of a name. They just call it straight polynomial. Okay? So the first level thing that you have to be able to do is look at them and identify, number one, is it a polynomial? And what type of polynomial, if it can be a distinct name like monomial, trinomial, or binomial. Now, some things you have to remember is that variables, when we have exponents on them, they can only be positive, okay? So we could not have 3y raised to the negative 2. That would not be a polynomial. We also can't have variables on the bottom. So, for example, in a division problem, so if we had 3y divided by x, that is not a polynomial. We could have 3y divided by 2, this would be a monomial, but this one, because we have a variable on the bottom, is not even a polynomial. So you have to think about those things. All right, so the first one, we have a number being multiplied with a variable that has an exponent, and remember, it's just one combination. This is a polynomial, and more specifically, it's a monomial. I'm just going to abbreviate there. So let's look at B. We have 2/5 x, so that's a number with a variable as a product, so that's a monomial, another monomial, and then this 4 here is a monomial. It doesn't have any variables, And it also is called a constant. So remember what constants are. It's called a constant, and that's something you need to remember. So in this case, we have 3 terms. So this would be a polynomial, but more specifically, it's a trinomial. All right, let's look at C. When you look at C, I have a star to kind of help you know, something's going on here. Notice I have a 3x plus a y plus another x. This x and this 3x are like terms. They can actually be combined together. So this actually simplifies down to 4x plus y, and that gives us 2 terms, which means it's a polynomial, but it's a binomial. Okay, so make sure you always look for any like terms to combine, and you do that with the like bases. All right, let's look at D. Now, this is one term, so this is a monomial, and it's being combined with another monomial. There's no variables on the bottom, so this is a polynomial, and more specifically, it's a binomial. Now, if we look at E, and we already talked about this, when we have variables on the bottom, this is not a polynomial. So we can't even classify it any further because it's not a polynomial. These are rational expressions. Rational expressions have variables as their denominators. So we want to remember these are rational, and those are variables in the denominator. We can't have that to be considered a polynomial. All right, the next level thing you have to figure out and to be able to identify are degrees of monomials. So degrees are a sum of all the variable exponents. So we look at every variable. It doesn't have to be like terms. We're just looking at the exponents. So, and we're only looking at the variable exponents. So our x is a variable and our y is a variable. We're going to look at that exponent, 3 and 2, and we're going to add them together. So 3 plus 2 is 5. So this has a degree of 5. It's one monomial. We're just talking about a monomial because it's one whole term, but we add up the exponents of all the variables. Again, B is one whole term, so it's a monomial, and we're going to add up the exponents. So we have 4, 3. Remember, if we don't see 1, we know there's a 1 there. So this is actually 4 plus 3 is 7, plus 1 more is 8. This has a degree of 8. Now, we don't see any variables in C, which means we can't count its exponents, so this has a degree of 0. Any constant has a degree of 0. All right, now when we go a little further, if we're looking at polynomials, so we may look at trinomials, binomials, even bigger than that are just polynomials, we're going to find the degree of those. So what we have to look at is the greatest degree of any monomial in the polynomial. So these are individual monomials, and kind of take a quick look and make sure there's nothing that can be combined. I don't see any like terms that can be combined. So I'm dealing with 4 individual monomials, and I'm going to look at each of them and see what their degree is individually. So back to monomial. So this variable has a degree of 2. So this one's 2. This has a 2, and then there's a 1 there, even though we don't see it. So this one has a 3. There's a 5 there. And then remember this one, it has no variable, so this has a degree of 0. So we're looking for the greatest one. So obviously 5 is bigger than 2, 3, and 0. So the degree of this whole polynomial is 5. Let's look at B. We have a monomial, and a monomial. So there's 3 of them, 3 terms. That gives us a trinomial if we were having to clarify it. And we want to see what the greatest degree of this polynomial is. So in this first one, x has a 1, so this is a degree of 1. Remember, any constant that doesn't have a variable has a degree of 0. And then this one has a 1 and a 1, so this degree is 2 for this monomial. So the whole polynomial has a degree of 2. All right, let's talk about standard form. So when we write polynomials, we write them in standard form. And writing in standard form means that we're writing them either in descending or ascending order by degree. If it doesn't say, then we're going to write them in descending. Now remember that descending means to go from large to small, and ascending means to go from small to large. Okay, so if it does not say, we do it descending. So the biggest number or biggest degree goes first. So let's look at our first example here. We have a pretty large polynomial, lots of little pieces. But if we look at it and break it down, we have one term, two terms, three terms. This is a trinomial. And we're going to look and see what our degrees are individually. So we're looking just at our variables. So this has one of 5. This has a 7 and a 3, so this has a degree of 10 for this binomial. This has a 1 and a 3, so this has a 4. So we're going to write them in standard form, which is descending. So we put the one with the largest degree first. So this whole term here that's worth 10 is going to get written first. So 12x to the 7th, y to the 3rd. So that one's done. Then we're going to our next biggest, which is this 9x to the 5th. So plus 9x to the 5th. And then our last one, negative 4xy to the 3rd. Now this is written in standard form in descending order. All right, let's look at our next one. And this one I'm going to have you write in ascending order. And honestly, you don't see these very often other than when you first learn and know how to practice with these. You don't see it very often. Usually it's descending. So first we're going to look. We have one monomial, two monomials, three monomials, four monomials. So this is just a polynomial. Now we're going to find the degree of each one. So we have 2 and 4, so that gives us a degree of 6. We have 4 and a 1 here, so that gives us a degree of 5. We have a 1 and a 1, so that gives us a degree of 2. And there's no variable on that negative 10, so that's just a degree of 0. So now we're going to write them in ascending order, which means we are going from small to large. So the smallest one is that negative 10, because it's 0. Then it would be that 5xy. We got those two. Then it would be negative 4x to the 4th y. And then the final one, 3x squared y to the 4th. This would be your final answer of this polynomial written in ascending order based on degree. All right, let's look at C. So this one asks to write them in descending order. So again, if we look here, and we look here, we've got two monomials, so that means it's a binomial, and we're going to find our degrees. We have 4 and a 1, so we have 5, and we have a 2 and a 3, and we have 5. So when they're the same, it doesn't matter which order we write in, it's descending or ascending. What usually people like to do is look at the leading coefficient. Remember, that's the coefficient that starts out the polynomial, the leading coefficient, and put the bigger one first. So then we would leave it like this. You could rewrite it as 2x squared y cubed plus 3x to the 4th y to the 1, or leave off the little 1, and that would still be acceptable because they have the same degree. All right, D. We're going to put this one in descending order in terms of x. So all we're looking at when it says in terms of something is the x variable in each one. So we have a monomial, monomial, monomial. This would be a trinomial if we needed to name it. And we're just going to look at the x's. So we're looking at this x, and this x. So if we're only looking at the x, we're looking at the degree just for this x. So that's a 2 degree, 3 degree, 4 degree. And if we're putting in descending, remember what descending means. We're going from largest to smallest. So 6x to the 4th minus 12x third y plus 24x squared y squared. Now we don't just write the x's when we write them, we write the whole term, but we're using x's to tell us what order to put them in. So this would be your final answer. Now, remember if we're talking about what a leading coefficient is, that's the number. So if I have to reorganize this one, the leading coefficient here would be 6. If I ask you to tell me the total degrees, you need to know how to do that. You need to write them in terms and be able to use your vocabulary.